If Bob at acme.com wants to send email to Sally at tesla.com, how is Bob's email delivered to Sally's company, which in our example is tesla.com? You might be wondering why email is a cybersecurity topic. Let's find out in this video. Bob writes the email and hits the send button. That email goes to Bob's company's outgoing MTA, short for Mail Transfer Agent. Since the domain is not of its own, it delivers the email to tesla.com inbound MTA using SMTP, short for Simple Mail Transfer Protocol. The email is received and then placed in the mailbox of Sally. That is, if all the email security checks pass all the criteria. Email security checks could be a lot of things. For example, sender reputation score, SPF, DKIM, and dmarc check. Could be virus, phishing, spam check, and maybe additional check based on Tesla email security posture. But first, how does acme.com MTA knows where is tesla.com? That is where DNS comes into play. DNS stands for Domain Name System. All communications on the Internet are made possible by IP, short for Internet Protocol. Every single computer has an IP address, and that is the same thing for MTA. The DNS knows what the IP addresses of every computer. Well, that is half correct. The DNS does not know every single IP of every single computer on the Internet. When I say computer, that includes your cell phones, tablets, and anything that communicates to the Internet. DNS topics are complex on their own. To simplify, let's add a root DNS in our drawing. The root DNS knows all the different DNS in the world. Authoritative DNS, that is. Think of authoritative DNS as the owner of the domain and all its DNS records. For example, let's say the DNS on the left is the authoritative for acme.com, and the DNS on the right is the authoritative for tesla.com. If the acme.com DNS does not know the record for tesla.com, it will query the root DNS to find where the acme.com DNS is. Once it finds out, it queries the MX record of acme.com. Like I said, DNS is a complex environment on its own, so let's leave the DNS portion for now. Let's focus on how the MTA IP address is resolved. First, let's do it manually. In Windows, there's a tool called nslookup. If you run nslookup tesla.com in PowerShell, you will get the IP addresses of Tesla. Google also has a DNS online tool. If you go to toolboxgoogleapps.com, select Dig, then enter tesla.com. Click on the A tab for the IPv4 addresses. You will see the same results as the Windows nslookup. Now so far, the IP addresses we see under the A record are likely the tesla.com web server IP addresses, not the MTA IP addresses. I said likely because they could be for other types of service. To find the MTA IP addresses, we need to look at MX record first. In the Google toolbox, click on the MX tab. Here we see the Tesla MTA hostname. Other companies may have multiple host names here. To see the IP addresses for the MTA, we need to query the hostname. Now the A record is showing all the different MTA IP addresses for Tesla. Every single one of these IP addresses is an MTA IP address. Inbound MTA to be exact. In large corporations, inbound MTA are different than outbound MTA. Now let's go to the Windows PowerShell. We can type nslookup -type equals mx.tesla.com. Now we see the MTA hostname. We query the hostname again to get the IP addresses of the MTAs. These are the same IP we see in Google Toolbox. Now let us see this in action using our diagram. To resolve the Tesla.com MTA IP address, the Acme.com MTA will send a DNS query asking for the MX record of Tesla.com. It will receive MTA hostname. A second DNS query is sent to get the IP addresses. When the response arrives, the MTA stores the data in its own cache storage. So the next time it doesn't need to query the DNS. Since there are multiple IP addresses received, the Acme.com MTA will decide which IP address it will use to send the email. The next time it needs to send email to Tesla.com, it will choose the next IP address in the cache. So eventually, it load balance between all the IP addresses of Tesla.com. Now let's see how the SMTP connection works. Acme.com MTA initiate a TCP connection. We are skipping the IP protocol part in this flow. The Tesla MTA responds with 220 with its own hostname. Then the Acme.com will send hello. It's a type of SMTP protocol code. Within the hello its own hostname. If the connection is allowed, the code 250 is sent. If Acme wants to establish using TLS protocol to encrypt the data, it sends start TLS. Then Tesla will respond with 220 go ahead TLS if it's capable of TLS connection. We will skip the TLS negotiation flow since TLS is another complex topic, but I will cover TLS in future video. Finally, the email is sent over the TCP connection. If you study networking, you are familiar with OSI layer. Here is what the SMTP protocol layer looks like. If we look at Acme.com MTA, these are the protocols running in it. The Tesla.com MTA has the same protocol layer, and its layer communicates with its other. The IP layer communicates to IP layer, TCP to TCP, and SMTP to SMTP. This is how it makes it possible for machines to communicate with another machine using the protocol that they both understand each other. It's no different than people's language. We need to communicate in the same language, otherwise we cannot understand each other. Of course, in some cases, people speak different languages, but there is a translator for one of them. Now let's see SMTP protocol from a Wireshark packet capture. Wireshark is a popular networking tool to analyze packets. This is an SMTP packet capture example. You can download it directly from the Wireshark website. This is a capture between a client email application and the first MTA. So it's a little bit different than what I described between the two MTAs. We can still use this to see some of the flows that we just learned. The first part of the packet captures the DNS query. In this example, it already knows the MTA host name. So the MS record query is not showing anymore. The DNS response provides the IP address of the mail.patriots.in MTA. The next three packets are called TCP three-way handshake. The three-way handshake makes it possible for two machines to establish a connection. Notice the destination is TCP port 25. This indicates the source is requesting SMTP connection. After the handshake, the two machines are considered connected at TCP layer. Now the SMTP conversation starts with the recipient sending 220, indicating it's ready for SMTP conversations. The sender then sends a hello with its own MX host name. In this example, its name is GP. The next packet are the user login, and when the user is authenticated, what follows is the SMTP mail from address of the sender. The mail from address is not the email address that you see in our inbox. Imagine you write a formal letter on a paper. At the top, you will include your mailing address. You fold the paper and then put it inside the envelope. Now outside the envelope, on the top left, you will write your own address. That is your envelope address, or mail from address. And it is also your return mail address. That is the best analogy what the mail from is. in the SMTP context. The recipient address is also shown as RCPT2. And then the next packets are the actual content of the email. This packet capture example does not use encryption, therefore we do not see the start TLS. Now you have seen how the SMTP protocol is initiated so the email can be delivered to the intended recipient. This is a high-level view of email delivery. It is a lot more complex than what I have presented. What happens when a person impersonates Elon Musk in emails? There are so many smart people out there who can write a script that can send email. It's so easy nowadays. You can ask ChatGPT to write you an SMTP script, and in no time, if you are smart, you can send an email pretending to be someone. Let's say someone inside acme.com crafted an email and changes the from address to Elon Musk. That email is sent to the outbound MTA, then delivered to the tesla.com inbound MTA. This is where cybersecurity comes into play. One of the defense is called SPF. The mail will be rejected because of SPF. SPF is short for Sender Policy Framework. It's an email authentication protocol designed to prevent email spoofing, a common technique used in phishing attacks and email spam. As an integral part of email cybersecurity, SPF enables the receiving mail server to check whether the incoming email comes from a domain authorized IP addresses. In our example, if the email comes from elon.musk@tesla.com, entering tesla.com domain, the MTA check if the sender IP address is an authorized sender of tesla.com. If not, it will reject the email. And that's the basic example of SPF, how it works. In future video, we will dive into how SPF, DKIM, dmarc, and BME work. I will also show you what you need to know about dmarc for different types of email delivery scenarios, such as when there is auto-forwarding or when your company wants to send email using your company's domain from a third-party system. For example, you want to set up acme.com within the salesforce.com. All this will help you to set up your email to make them pass spam check and be recognized as authentic emails. I hope you learned something in this video. I will see you in other videos.